Wait a minute. Streaming. There we go. Connor, turn it off. Mute it. All right, guys, I see there's two of you there. If you have any questions on any of the ones in the review sheet, just say what problem number, and I can redo it or do what you need. If you want to see one of the problems worked out in the review sheet, just type what problem number. Any questions? Hi, Ari. All right, number 13. Okay, the question is number 13. So we're going to use product rule. All right, so we got 3x to the fourth times the second plus, we'll repeat it out. All right, the derivative of the first times the second plus the derivative of the second times the first. All right, this front part becomes 12x cubed and this becomes simply 5e to the x. Again, constant multiple rule says just differentiate the function part and tack your constant back on. So if we clean that up, we basically get not much we can do. So we got 12 times 5, so we got 60 x cubed e to the x plus 15 x to the 4th e to the x. And that's fine. I think it was raised in the second class, but let's say you get this as an answer. All right, and then you go further to try to clean it up, and you mess up on the cleaning up part, I will still give you credit because there's the derivative. I'm not going to be so hard right now in the beginning of the year on your algebra and your trig because that'll come. But we could go further. I can pull out a 15. I could pull out an x cubed. And I can pull out an e to the x. All right, I'd be left what? With 4 plus x. Okay, so it cleans up a little bit, but again, it doesn't really help me out or do anything much other than making it a little smaller. Okay, but let's say again, if you got this correct, and then somehow down here you messed up and simplified it and made a mistake, I will still give you credit. Is that okay? You good, Ari? All right, number 15. All right, let's go jump to 15. All right, we've got square root of x times sine of x. All right, plus square root of x sine of x. Derivative of the first, derivative of the first times the second plus the derivative of the second times the first. All right, here we go. Square root of x is really x to the 1/2. All right, so that becomes, 1/2 x to the negative 1/2 times sine of x. All right, and then we're going to do derivative sine, which is cosine of x. All right, and I'll just, for the fun of it, leave this as x to the 1/2 cosine of x. So that's it. All right, we can clean it up a little bit here. So I do want negative exponents simplified. So don't leave any negative exponents. So really, in this first term here, the sine of x is in the top. All over 2 times the square root of x, or x to the positive 1/2, either one, plus square root of x times cosine of x. Okay, so either one's fine, but traditionally we can leave it like this. And I'm perfectly fine with that. Okay? All right, so whoever wanted number 15, you're writing in Chinese there. So that would be the answer to 15 right here. Okay? For 13. Can we get 15 out first? Oh, I got you. I'm sorry. I get what you're saying. So, all right, yep, absolutely you can do that. All right, so I'm going to erase 13. Well, I won't erase 13, but let's bring it over here. Here's 13. Notice it's 3x to the 4th, 5e to the x. And remember we said that on some of these problems you may want to clean it up before you even start differentiating. And you could bring the 15 out front. 3 times 5, x to the 4th, e to the x. And the constant multiple rule says what, guys? Differentiate that part and then just tack your constant 15 back through. So you'll still get the same answer. So let's kind of do it quickly here. 4x cubed e to the x plus x to the 4th e to the x times 15. And then all you would do is you could pull out 4x cubed e. They absolutely could pull the 15 out first and ignore it. Okay? Good eye. It's whatever you feel comfortable with. There's no right or wrong way to do that. Okay. Again, this video will be up on YouTube afterwards. It records it so you can kind of rewatch it if you need to. All right. Any other questions? I did put an extra credit on the test, so it's actually kind of easy, but we'll see what you get. And so, you know, it doesn't hurt to become familiar with some of your trig identities. You know what sine is. I mean, you have cosine of x and tangent of x. So 1 over sine of x is cosecant of x. 1 over cosine of x equals secant of x. And of course, 1 over... Realize some things like this. What is sine of x times cosecant of x? Well, cosecant is 1 over sine. So they kind of cancel. So that really just turns into 1, right? So knowing some of your trig identities can help you clean up the problem before you differentiate. Okay? So knowing some trig identities won't hurt you. You don't have to do it, but it's good to know. All right, how's everyone else doing? Any other questions? Don't get fooled by stuff like that. You know, we've got a pi. We know it's a constant, and the derivative constant is 0. Okay? Identities. Should we focus on the Pythagorean ideas too? No, let's not go that far yet. Okay? Ariana's asking about the Pythagorean versions of them. And what she's talking about is, remember this stuff? Sine squared plus cosine squared of x, well, equals 1. All right, and then from that we get some versions of it, meaning sine squared of x is equal to 1 minus cosine squared of x. And then likewise, cosine squared of x is equal to 1 minus sine squared of x. Okay, and all I'm doing is moving cosine squared to the other side and vice versa. Okay, so these are kind of the Pythagorean versions of sine and cosine. You should not have to know that right now. Okay, we're trying to zip through all the differentiating rules. We've got one more to go, and then we're going to do some problems, like word problems, and then we'll take maybe a few days and go over some trig stuff. Okay. If you just feel like you want to do more problems, feel free to. All right, I'll tell you, if you want to get more practice. All right, let me find a page in the book for you. Does your student textbook, guys, have the odd answers in the back of the book? If so, then do some odds from. Hold on, let me get you a page number here. That batch, odd. All right, so do some of those and, practice, and then you can check yourself and make sure you got the right answer. Okay? So I'll sit here for a little bit if anybody wants to find a problem. In fact, while you're looking, I'll give you another problem. Sometimes you may have to do a couple parts to a problem. Notice this one's kind of got a product rule, and then you just differentiate the end of it. So it's almost like, you know, 3 parts to it. This part is the product rule, so that would be derivative of x times sine of x plus x times the derivative sine. And then this is its own little guy down here. This is, you just do cosine of x prime by itself. So then to finish this, the derivative of x is 1. So sine of x plus derivative of sine is cosine. And then you got cosine of x like that. Okay? And I'm okay leaving this, okay? But, you know, you could do something like this. Sine of x plus cosine of x, x plus 1. Okay? So it's up to you, but, you know, be careful how you've got, you could have a product rule and then have some more stuff here. And always try to rewrite first. You know, if you've got x squared plus 3x plus 1 all over x, don't do the quotient rule. Clean it up first. This is a common denominator, so it'd be x squared over x plus 3x over x plus 1 over x. So that cancels, and I'm just left with x to the 1. That cancels, and this is just x to the negative 1. So I've not even differentiated yet. Now we differentiate. Derivative of x is 1, derivative of that is 0, and this becomes negative 1 over x squared. I just did it real fast. So it'd be negative 1 x to the negative 2. Okay? So do some cleanup, then differentiate. All right. And like I said, I'll have the rule sheet with all the differentiating rules probably up on the board. Just I'm gonna save some paper, and that way it won't. I don't have to print it out, so it'll just be up on the board. Okay, guys. And go with first instinct, and always try to identify constants. I'm looking at the book now, and I really don't see anything that's abnormal. I don't see anything that is not on the review sheet. And you don't have, like I said, you do not have to evaluate the derivative at a point. Okay? All right, I got a request for number 45 in the book. All right, and when you type in the chat, that's pretty instantaneous, and so I think the video and my voice is kind of about 3 to 5 seconds behind. So anyway, all right, so we have negative e to the x plus tan of x. What you can look at it, Ari, is that the negative 1 is kind of like a constant, right? Think of it like this. Negative 1 times e to the x. All right? And it's almost like constant multiple rule says you just differentiate this part and then tack your constant back on. So the derivative of negative e to the x is just simply going to be negative e to the x. Okay? And then what's the derivative of tangent? Okay. That should be secant squared of x. And you're done. Does that make sense, Ari? Excuse me. Okay, any others? Okay. Ah, gotcha. All right. Any other preguntas? Like I said, there's 25 questions and 1 extra credit. Any other questions? All right, guys. Well, I'll hang out for another minute or two. If you're trying to do some out of the book, I can sit here for a little bit, and if you get stuck on something, I can try it. The only other thing I want to mention that you want to be careful of is the variable that I use. Okay. If I ask for ddx of x squared plus 1, that basically means I differentiate with respect to x. So that would be 2x. But if I go d theta of sine of theta, make sure you say cosine of theta, not cosine of x. Okay? So knowing what variable you're using is very important. I should get some elevator music while y'all work problems out. All right. Yeah, again, I'm looking in the book and I don't really see anything that's different than the review sheet. So just make sure you really understand the review sheet and take your time. And the way the test is going to look is I'm not going to give you a lot of space on my copy of the test to work out your problems, because some of you can do it in a real small part and some of you take a huge amount of room. So you're going to have my test. It's just 2 pages. And then make sure you bring some notebook paper and do all your work on your paper. Okay? All right. I see only one person's left, so I'm going to call it quits. And I think you guys will be fine, or whoever there. I think you'll be fine. So, all right. Have a good night, and see you tomorrow.